So we're going to start off by saying that a vector is something that has both magnitude and direction. So let's define this a little bit. What do we mean by magnitude? Well, magnitude is just saying how big something is, and it's referring to the size of the number. Direction is just telling us if something is pointing one way or another. And when we're talking about it in terms of a number, that direction is given by its sign. For instance, a number can either be positive or negative. We also can give direction with angles. Now that we've defined magnitude and direction, let's start talking about how we can actually represent these vectors. We can represent vectors with an arrow. The important thing to note, though, is that every part of this arrow matters. So the length of the arrow is going to represent the magnitude. And again, when we say magnitude, we're just talking about size. Our arrow is also going to be pointed in a certain direction. And the pointing, if you will, of that arrow is just talking about the direction. So here's a real quick example of this. I have an arrow here. We can tell that it's kind of long and it's pointing to the right. So I would say that my magnitude is the length of this arrow and the direction is the right. Now, if I were to take my arrow and point it upward, I would say that this arrow has a small magnitude because it's a tiny arrow, and its direction is now up. Let's say, though, that we aren't given a picture. So let's pretend that we have an example, but this time we don't have an arrow. We just have a word problem or something. So here's 3 examples of vectors and different ways that we can talk about their magnitudes and direction. So here I have 5 meters per second to the right. The 5 is referring to my magnitude, and the right is referring to my direction. Let's look at another example here. I have 2 newtons up. Again, the 2 is the number that's referring to my magnitude, and the up is my direction. That's telling me where it's pointing. Let's just look at one last example real quick, and let's say we have positive 3 meters per second squared. The number is referring to my magnitude, and the positive is referring to my direction. And we're going to say that 99% of the time, positive is going to mean one of 2 directions. So positive is either going to mean the right or up, and then negative is just going to mean the opposite. And again, we're just saying this because if we look at a graph or a number line, all of our negative numbers move to the left and move down, and all of our positive numbers move to the right or up. Let's talk about a few examples of what vectors are. So what are some quantities or some things that are vectors? So we just said that a vector is anything with magnitude and direction. So we need to think about what quantities have we come across so far that have a number and a sign associated with it. Well, we've talked about velocity, right? Velocity can be positive 10 meters per second or negative 10 meters per second. So velocity is going to be a vector. We talked about acceleration. Acceleration can be positive 10 meters per second squared or negative 9.8 meters per second squared. We also have talked a little bit about displacement, and displacement can be positive 10 meters or negative 10 meters. Displacement is how far we are from the origin, so we could basically be in front of the origin or behind it. And lastly, this is something that we'll talk more about in the future, but force. Force can be a positive value, like positive 10 newtons, or a negative value, like negative 50 newtons, depending on which direction we are putting our force in. So now that we've talked about vectors, let's talk about scalars. So scalars are a lot easier than vectors, and we're going to define scalars as quantities that only have magnitude. So scalars only have magnitude, meaning that they do not have direction. So when we think about a scalar, we're thinking about a quantity that basically can only be positive. So what is something that can only have a positive value? And again, this is just a simplified way of thinking about it, but will hold true for almost all the cases that we'll talk about. So what's something that can only be positive? Well, distance can only be positive. If I travel to the door, which is 10 meters away, I walk 10 meters. If I walk back to my seat, which is backwards, I'm still walking 10 meters. I cannot lose the distance that I walked. So distance is always positive. Therefore, distance is a scalar. Another thing that is always positive. Well, let's think about our car. In our car, we have a speedometer. That speedometer only has positive values on it. The speedometer tells us our speed, so speed is another example of a scalar because speed is only positive. Another thing that can only be positive or only have a number associated with it is mass. We are not able to have a negative mass. It does not exist. And then lastly, the other thing would be time. And again, there are tons of examples of scalars out there, but these are the main ones that we're going to focus on. Now that we've discussed the difference between vectors and scalars, we're going to look at the math associated with it and what we have to do when we want to add two vectors together. You are going to get what we call a resultant vector. A resultant vector is just the sum of those two vectors. And I want to show you really quickly how that works. So let's say we have these two vectors here. We have one vector pointed to the right, and let's say that that's 7 meters per second. And then we have a second vector pointed up. And we're going to see that this vector is 4 meters per second. If we wanted to add these two vectors together, we would need to use trigonometry because one is pointed to the right, so one is horizontal, and the other is vertical, pointed up. The way that we combine our vectors is we add them head to tail. And what I mean by that is this. Here is my first vector of 7 meters per second. The head of the vector is right here. Okay, so again, this is the head. And then the tail of my second vector is down here at the bottom of it. So head to tail. And then how do I find out what my resultant is? Well, my resultant goes from the tail or the beginning of my one vector to the head of my last vector. So this is going to be my resultant. So now we can see that we formed a right triangle, right? This one is horizontal, this one is vertical. It forms a perfect 90-degree angle, and we get some sort of angle here as well. So adding these together, we're just going to use Pythagorean theorem. And again, in case you forget, that's just a squared plus b squared equals c squared. So I can assign any of these to be a or b. So let's say this is a, let's say this is b. This has to be c because it's my hypotenuse. So I get 7 squared plus 4 squared equals c squared. I simplify and solve, and I find out that I get 65 is equal to c squared, square root both sides, and I find out that c is equal to 8.1 meters per second. So my resultant vector is 8.1 meters per second. But hold up, this isn't my final answer. This is just the magnitude. We said before that direction can be represented with a positive value, a negative value, a word, or an angle. In this case, it's going to be an angle. We can see here that my vector is pointed up at a certain angle. Well, in order to figure that out, we're going to need to bring back, again, some basic trig. So here's our triangle, and I'm just going to fill in my values that I just got. So this is 8.1, this is 7, and this is 4, and this is 90 degrees. And I want to figure out what this angle is here. So I can use any of these numbers to do it, but I will have to use some sort of inverse trig function to do it. I would recommend using the numbers that you were given if possible, and not using the number that you calculated. So for instance, I would use inverse tangent. And I know that inverse tangent is opposite over adjacent. So if my angle is right here, the opposite is 4, and the adjacent is 7. And this is equal to my angle, theta. And again, this symbol just represents angle, and we call it theta. So theta equals angle. The most important part here is making sure that our calculator is in the correct mode. So make sure your calculator is in degrees before you do this. I know in your math class, sometimes you guys go to radians, but always check and make sure that you're in degrees for this. So I have inverse tangent of 4 divided by 7. I find out that my angle is 29.7 degrees. So putting this all together, it would look something like this. My resultant is 8.1 meters per second at 29.7 degrees. This value right here is my magnitude, and this value right here is my direction. When we say this angle is always referring to the angle from the horizontal axis. Now that we've looked at two separate vectors and combined them into one total vector,
we're going to take one vector that's at an angle and resolve that vector. Resolving a vector just means that we're taking that vector and splitting it up into its x and y components.
So here's an example of us doing exactly that. Let's say that we have some vector and it's pointed at this angle. And let's say that it's a force vector. So we're going to say that our force is 10 newtons.
All the angles that we talk about are in reference to the horizontal axis.
So if I put my horizontal axes right here, I can see that this vector is creating an angle. So I know that this angle, because it's given to me in the problem, will be 30 degrees. So now I need to split up this vector into the x and y components. Y component is going to look something like this because it's completely vertical. So this is going to be my y. And my x is going to look something like this because the x is completely horizontal. The x and the y will always be perpendicular to each other, creating a 90-degree angle there. And we're just going to go ahead and split it up by using some trig. So we need to figure out what the y is and what the x is. Well, we should remember for trig, we have sine, cosine, and tangent. Let's start with y. So if we want to figure out what the y side is first, we're going to have to do sine. And we know that sine of theta is equal to opposite over hypotenuse. So we can just plug these numbers in. So I get sine of 30 degrees is equal to my opposite. Well, my opposite is y. I don't know what that is, but my hypotenuse is 10, so I can plug in 10 there. I multiply the 10 over. I get 10 times sine of 30 is equal to y. I find out that y is equal to 5 newtons. Remember, we always need to keep the units going, so remember to add your units there. Now we do the same thing, but we solve for x. So I have cosine of theta is equal to adjacent over the hypotenuse. I plug in my numbers. Cosine of 30 is equal to adjacent, which I don't know, but we said the adjacent is my x, over the hypotenuse, which is 10. I multiply the 10 over just like I did before. I simplify and solve. I find out that x is equal to 8.66 newtons. So the important thing to note here, right, is that our y value was 5 newtons. What direction is that pointed in? Well, 5 newtons is the same as positive 5. The positive is telling me up, and the 5 is telling me the magnitude or the size. Same thing here. My x is positive 8.66. The positive is telling me to the right, and the 8.66 is telling me the size or the magnitude of that force. So vector has magnitude, meaning that basically it's a number, and direction. And we said that direction can be given to us in many ways. It can be positive, it can be negative, it can be up, it can be down, it can be left, or it can be right. And a scalar is just something that only has magnitude. So again, when thinking about a scalar, that's a quantity that we're only given the number, and we need a context clue to figure out what direction it's moving in. If it doesn't give us a direction, then it's a scalar. So velocity and speed are commonly confused or interchanged with each other because they're very similar, but they're not exactly the same thing. For velocity, we always know a direction. So if we said our velocity is 10 meters per second, that's telling us that we're moving in the positive direction 10 meters per second. But if I said my speed is 10 meters per second, well, that could mean I'm moving left, I'm moving right, I'm moving forward, I'm moving backwards. I don't know what direction I'm moving in. And that's the difference between vectors and scalars. Vectors will tell us how big our number is or the magnitude, and also what direction that number is pointing in. Where a scalar will only tell us how big that magnitude is, and we'll have no idea what direction it's pointing in. And then always remember that when you're adding, you have to add head to tail. I have an arrow here. Here's the head of my one arrow. Here's the tail of my other one to my head. Boom. And I would recommend too that when you're adding, start with the x vector and then add the y vector. The reason I say this is because the x vector, if we start with that, that's our horizontal axes here. So all of the angles that we're given now are in relation to this vector, okay? If you start with the y instead of the x, you're going to be getting some weird angles. So just make sure that when you're adding vectors, you always start with the x and then add the y on to the head. And lastly, like we said, if we have a resultant vector and we need to resolve it into its x and y components, we're going to need to use trig, so cosine or sine. And if we simplify those forms, we find out that we just get VR for our resultant vector times sine of theta is equal to Vy. And also VR for our resultant vector times cosine theta is just equal to Vx. And again, this is just our trig formula, but I've just multiplied the hypotenuse over to the other side to just isolate the x and y components of the vectors.